In this video, you're going to see two examples being worked out with regards to what we call annuities. So remember that annuities were special types of investments where the same amount of money was being either deposited or paid back on a loan at regular intervals, be it daily, monthly, or yearly. So what we'll see in this video, two examples, one concerning future value, that is putting in or depositing money at regular intervals to generate a future value, okay, that is worth more than what you've put in to begin with. And the other situation involves present value. And present value generally deals with amounts that are loaned or amounts of money that are borrowed. Okay, so we're also going to use the TVM solver through a number of these examples. And in fact, a lot of your annuity problems will be solved using the TVM solver. So here's the first one. This is number 2. Your task, or our task, was to determine the number of monthly payments. Okay, so we're looking for monthly payments. So that's our PMT in this case. And recognize that it is over a monthly interval. Okay, what we're looking to do is to generate a future value. Okay, so that's critical, future value. So I'm just going to also highlight some of these variables down here so we have an understanding of what it is that we're trying to find out. The future value is going to be 10,000 in this case. So we could put that in here, $10,000. Okay, what I've conveniently done too is over here I've put in all the definitions, okay, for each of the variables so that you know what they mean when you're using the calculator. Let's read a little bit further and see what else we're up against. We have 4 years. Okay, so that's going to be critical too. And we have an interest rate of 6.5%. Okay, so that can go in. Just going to highlight or color code that too. 6.5, that's your I right in here. Let's see, present value, not a concern in this problem because we're looking for the future value. So I'm just going to cross that out. On the calculator, we'll leave it as 0. If you take a look, the compound is going to be monthly. Okay, so that's important. And also take note that the compound monthly, that's 12, is the same as the frequency of the payments. So that's critical in what we're doing here. So these two numbers will both be 12s. So you'll generally find in a question 2 areas or 2 phrases that are going to suggest the compound. Well, that's not what I wanted to do there. Suggest the compound as well as the payments per year. Okay, so we'll color code everything so we can kind of see where things are coming from. Now, if we stop there and we just focus on filling in the information in this template, once that's done, we'll surely generate an answer that we can use to solve the rest of the problem. So let's deal with the N. So if you take a look at the frequency of payments, we're dealing with monthly. Okay, so N represents the total number of payments. So in this case, right, we're going to take the number of compound, or sorry, the number of payments per year. Okay, and we recognize that that's going to be 12 in this case. Okay, and we're going to look at how long the investment is for. Okay, so for 4 years. So we'd have 12 by 4, which is equal to 48. Okay. So at this point in time, if you have any questions, just ask me to pause, and we'll discuss some of the values that have been put into the template. All right. So moving forward, let's grab the TVM solver. Okay, and what we're going to do is I'm just going to reset my calculator. I need to do that in order to solve. Okay, so I'll go into apps and double ones. So 1, 1, and we'll enter the values. Notice that when you enter PY, that CY defaults to 12 as well. The only time that that will be important to really watch is when we do some mortgage problems. The payment and or deposit, depending on the scenario, is going to be at the end. So unless otherwise stated, always leave it at the end. Now, according to the problem, you are after the payment. Okay, so what we do is we cursor over top the value we want, we press alpha, right, the green key, and then enter. And what you can see is we have $182.98. Okay, 182.98. So minus 182.98. Let me just double check that, 98 cents. Yes, okay. Notice that you do get a minus. Now the minus means that because we're trying to generate a future value, you need to deposit money. So it simply indicates that money is being paid out of one's pocket. Okay? So the answer here for a monthly payment is $182.98. So you also have a template of this in your notes, so make sure that you do make a record of this. So last but not least, let's go back to the main problem and see what they actually want. If you read here, second sentence says, how much interest is earned over the annuity? Okay, so what I've done down here conveniently is set up is that an interest calculation for future value only is you take the future value and you minus the total deposited. So in that case, what we're going to do is determine the future value. Now, future value in this case would have to be all of the payments, right? So we made 48 deposits, and each deposit, right, correctly, is worth 182.98. That is rounded. Okay, so we'll do that first, and I'm just recognizing here that I'm a little bit is what I should be doing. That my apologies. That goes over here. That's my total deposited. Okay, so again, I should have known that. Must be thinking of the next question where we're going to do present value. So total deposited is this amount here. Okay, so hopefully what I just mentioned doesn't throw anybody off. So please take a moment to make sure that makes sense. And future value is given, right, as $10,000. So we work this out, right? Had I continued that error, think about it, I would have come up with a negative value for my interest, and that just doesn't make any sense. So the number we should get for interest in this problem is going to be positive. So let's minus, I'm going to open up some brackets here. So 48 multiplied by 182.98, close bracket, equals 1216.96. Okay, so there you have it, 1216.96. So over 4 years of depositing let's say $83 per month, every month for 4 years, the amount of interest you're going to earn is a little over $1,200. Okay, so one more video coming up. We'll try to keep them under 10 minutes, and that one's going to focus entirely on present value.